Good morning students, I am Dr.R.SUGANYA, Department of Computer Science with Cybersecurity. Today I am going to talk on case study on information science. Introduction to machine learning. Definition or theory, why machine learning is important and how it is being used, and what is machine learning and relation to animal or human learning and impact on information. And the topic used in IST, the probabilistic reasoning, digital libraries and theories in information sciences, that is the issues, unified theory or domain of applicability, conflicts, machine learning versus human learning. Theories can be like algorithmic or some quantitative. Quality of theories. Occam's razor, simplest machine learning method. Machine learning very popular in real world applications. It may be computational or mathematical. Changes in system that enable to do the same task are drawn from the same population, and there are two ways that a system can improve: by acquiring the new knowledge, that is acquiring new facts, or acquiring new skills. By adapting its behavior, it's solving problems more accurately or solving problems more efficiently. Herbert Simon, the learning is any process by which a system improves performance from experience. What is the task? Classification, categorization or clustering, problem solving or planning or control, prediction, others. Why study machine learning? Developing better computing system. Develop systems that are too difficult or expensive to construct manually because they require specific detailed skills or knowledge tuned to a specific task. Develop systems that can automatically adapt and customize themselves to individual users. Personalized users or mail filter. Personalized tutoring. Discover the new knowledge from large databases. Market basket analysis. Medical text mining, that is example migraines to calcium channel blockers to magnesium. Some related disciplines are artificial intelligence, data mining, probability and statistics, information theory, numerical optimization, computational complexity theory, control theory, psychology, neurobiology, linguistic philosophy. So human versus machine learning, cognitive science versus computational science, animal learning versus machine learning. Don't fly like birds. Many machine learning models are based on human types of learning. Evolution versus machine learning, it is adaptation is learning. An adaptive system is a set of interacting or interdependent entities, real or abstract, forming an integrated whole that together are able to respond to environmental changes or changes in the interacting parts. Feedback loops represent a key feature of adaptive systems, allowing the response to changes. Examples of adaptive systems include natural ecosystems, individual organisms, human communities, human organizations, and human families. Some artificial systems can be adaptive as well. For instance, robots employ control systems that utilize feedback loops to sense new conditions in their environment and adapt accordingly. Types of learning: induction versus detection, rote learning, advice or instructional learning, learning by example or practice, learning by analogy, discovery learning, others. Training is the acquisition of knowledge, skills, and competencies as a result of teaching of vocational or practical skills, that knowledge that relate to specific useful competencies. Training requires scenarios or examples. Many learning methods involve training. Training is the acquisition of knowledge, skills, and competencies as a result of teaching of vocational or practical skills and knowledge that relate to specific useful competencies. So there are types of training like supervised learning, which uses a series of labeled examples with direct feedback, reinforcement learning, that is indirect feedback after many examples, unsupervised or clustering learning, no feedback, and or semi-supervised. So types of testing: evaluate performance by testing on data not used for testing, that is both should be randomly sampled. Cross-validation methods for small data sets, the more data the better. How well the learned system work: performance on unseen or unknown scenarios or data. Which of these things is not like the others? So we know that, and we just which of these things is like the others and how. So the research on bond gap problems, the domain of my research in cognitive science in the bond gap problems is visual pattern recognitions and appeared first in the appendix of the book published by Russian scientist M.M. Bongard in 1967. So what was then the USSR, they became more widely known to the Western world when Hofstadter mentioned them in the book and speculated on how an automated system could be built to solve such problems. So here the visual pattern can be, the designs is being brought up in diagram, and usual of machine learning stages could be hypothesis data, training or learning, testing or generalization. So learning, why is this machine learning necessary? Learning is a hallmark of intelligence. Many would argue that system that cannot learn is not intelligent. Without learning, everything is new. A system that cannot learn is not efficient because it rederives each solution and repeatedly makes the same mistake. Why is learning possible? Because there are regularities in the world. Thank you.